this is going to take some work. Well, what's the domain? Well, the domain with E is all real numbers. Horizontal asymptote. Well, if I look at f of x as being equal to 4x over e to the x squared, if I take the limit as x goes to infinity of 4x over e to the x squared, this is 4 times infinity over e to the infinity squared. Well, this is another case of big divided by huge, so this becomes 0. And if I go to negative infinity of 4x over e to the x squared, this is going to turn out to be 4 times negative infinity all over e to the negative infinity squared, which is negative 4 times infinity over e to the infinity squared. Again, it's big over huge. This is also going to go to 0. So I have one horizontal asymptote, and that's y equals 0. X-intercepts. So since I'm dealing with 4x over e to the x squared, it's where the numerator equals 0, or x is 0, so it's 0, 0. Y-intercept is where x is 0, so it's 4 times 0 over e to the 0 squared, which is 0 over 1, or 0, so it's also 0, 0. X value of local minimum, maximum, if it exists. If I'm looking at maxes and mins, I'm now dealing with the first derivative, so I want to know where f prime equals 0. It exists everywhere because it's all real numbers. It has no VA. So f prime happens to be e to the minus x squared times 4 minus 8x squared. That gets set equal to 0. E to the minus x squared is never 0, but 4 minus 8x squared equals 0. 8x squared equals 4. X squared equals 4 over 8. X squared equals 1/2, or x equals plus or minus the square root of 1/2, which is approximately 0.7, or plus or minus 0.7. And their multiplicity 1. So I can pull my test point, and which is 0. So what do I have? I have e to the minus 0 squared times 4 minus 8 times 0 squared. E to the 0 squared, well, that's positive. In fact, it's 1. This is 0. That's positive. That's 4. So that's positive, change negative, change positive, or change negative, excuse me. So that means that negative, positive, here's a min. Positive, negative, there's a max. I have one of each. So x value would be, the minimum is at x equal negative 0.7, and the maximum is x equal 0.7.